share my screen. So today we are having a look at how we can get an A star in A-level chemistry. So the way I've designed this session is to split it up into high yield questions. So your big 5, 6, 7 markers, which include a lot of like calculations, a lot of wordy questions, and then also basically going through a step-by-step guide on how to basically tackle from now all the way up till your last exam a step-by-step approach on getting an A star. Now that includes literally how many hours you should be putting in a day, and in fact I've even included my own what's it called? Like my own diary pictures, like screenshots, if that makes sense, as to like to show you literal like proof of how I structured my 4 to 5 months before A levels. So that is the part that I think you're really going to benefit from, because I want you to see what the structure should be like and how much work you really should be putting in, and take it from someone who never used to get A stars naturally. I had to, work pretty hard for them. So hopefully it's something you guys do find beneficial. I can't see the chat, so what I'm going to do is after I answer a question, I'm just going to go and check the chat so that you guys, if you have any questions in the meantime, I can just answer them. So without further ado, let's begin. It's got a mixture of year 12 and year 13 content, because remember, you can't neglect what you've learned last year if you're in year 13. So we're going to start with refreshing our knowledge on a little bit of time of flight to see how much you really remember. Okay, so let's have a look. You've got in the time of flight mass spec of an ion of an isotope of tellurium with mass number Y, it travels along the 1.25-meter flight tube. So immediately in my mind, I'm like, okay, that's the distance with a kinetic energy of this much. So that's my EK. And the ion is taking this much time to reach the detector. So that's my time. Okay, so I'm immediately annotating what I've got in front of me. And feel free to have a go at this question as well. I'll check the chat in a sec to see like how you guys are doing with that. But let's have a look through this. So it says calculate the mass in grams. In grams, this is important because have a look. Usually mass is calculated in kilograms according to this equation. So we need to make sure we don't forget to turn that into grams of 1 mole of these tellurium ions. 1 mole. Got to remember that too. Use your answer to suggest the mass number Y of the tellurium isotope, and your Avogadro constant is given to you. So, first things first, let's have a look at our equation. EK equals half mv squared. Now, the v squared is essentially the same as distance over time squared, right? So if you are not directly given a velocity, if you're just given a distance and time, you can actually just use this little equation and substitute that as your v squared. So that's exactly what we can do, because we've actually been given our distance and time. So to work out our v squared, if we did our distance, which we got as 1.25, and our time, which was 3.00 times 10 to the minus 7 squared, that will give us our velocity squared, which we can directly input. Let me just pop that into my calc. 3 times 10 to the minus 7, which you should get as 1.736. And then there's a bunch of ones, which I'm not going to write the whole thing. I'm going to write ... to show that the number continues, times 10 to the power of 13 meters per second squared. So that is our velocity. Now that we know our velocity, we can basically substitute whatever else we know to kind of figure out what our m would be, right? So number 2, we know our EK is 1.88 times 10 to the minus 12, and KE and EK is the same thing. It's just kind of put differently, but it's the same exact thing. So equals half times m, which is what we need to find out, times 1.7361 ... times 10 to the 13. From here, it's fairly straightforward in the sense that you need to make sure you're rearranging this equation to isolate that M because that's what we're trying to find. So if you're someone who's amazing at maths, you can probably do this all in one go. But I would personally recommend doing it step by step. So it will take a bit longer. But it's good because the examiner is going to be able to see each kind of step that you've substituted that equation and then rearranged it. And it's also going to be helpful to you when you actually come back and check your answer. So I would recommend just splitting it up a little bit more, just to make your life a little bit easier. So I would start by actually bringing this over to this side. So it would be 1.88 times 10 to the minus 12 times 2 instead of times a half equals m times 1.736 times 10 to the power 13. Well, I've got to do the dot dot dot. And then what you want to do is obviously times these two together, which would give you 3.76 times 10 to the minus 12 on this side. And that is equal to m times 1.736 dot 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 times 10 to the 13. And if it does help you, you can actually number them as I'm doing here as like a step by step. So then finally, to get that m by itself, all we need to do is, again, bring this over to this side by dividing it. So 3.76 times 10 to the minus 12 divided by the 1.736 dot 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 times 10 to the power of 13. So if I do that in my calculator, 6, that should give you 2.1657 times 10 to the minus 25. Now, let's think about what I said earlier. This is my mass, but what is my mass going to be in? Right now, it's actually in kilograms because that's like our conventional way of writing the mass. But this question wants us to give it into grams, and that is one of the very like caveats of a 5 marker. It's going to ask you to do some kind of conversion. It's never really going to be just as straightforward as putting things into an equation and substituting it. So we've got to turn this into grams, but we also want to know how much is in 1 mole. So remember, how many particles are there in 1 mole? There are always the 6.022 times 10 to the 23 because that is our Avogadro's constant. And this is something that your amount of substance topic will cover. So if it's something that feels shaky to you, immediately you know that this is something going on your list for revision. And that's also something I want to cover later when I go through the step-by-step A-star approach. So I've got this in kilograms. I need to first times it by 1,000 to get it into grams. And then to find out how much is in 1 mole, I've got to also multiply it by my Avogadro's constant because that is going to tell me how much like of the ions, what is the mass of those ions in 1 mole. Right now, I just know what is the mass of an ion, right? But I need to know how much is that mass in 1 mole. So if I did the 2.16576 times 10 to the minus 25, etc., times 1,000 times 6.022 times 10 to the 23, that is a very long equation. So I would always put brackets over each like thing as I type it into my calculator. Okay, and that should give you your mass of 130.4 grams, right? So that is my mass in grams. Now it also says to use this to suggest the mass number Y of the tellurium isotope. So what it's trying to ask us is not the MR of the, because you can't have an MR of an isotope because your MR is all of your isotopes kind of put together to give you your final tellurium element, right? All it wants is the mass number of that one tellurium isotope in that 1 mole. So that's the difference between your MR and your mass number. Your mass number is referring to that one isotope, right? And it's always going to be a whole number. So mass number is a whole number and it's referring to that specific tellurium isotope, not tellurium element in general. MR, if it said, give me the MR, the relative molecular mass, then yes, I can do it as to one decimal point as you would, as you see it on your periodic table. So using that, my mass number of that tellurium isotope in specific would be 130, according to the logic that we need to have it to a whole number. This obviously won't make us round it up, it's just zero point 0.4. So we can keep it as 130, and that is our mass number of that specific tellurium isotope. I'm just going to check the chart. Oh, okay. That's fine. If you do have any questions, please just pop it in the chat. I'll come back to it in a sec. Because I'm going to start the next question now. Okay, so I think I'm going to do the 7 marker first because it is a little bit harder. So I want to get like the harder questions done first, and then kind of move on to the easier questions. And I will have some time at the end for Q&A in general, where you can ask me about not just A levels, but if you're doing interview prep, you can ask me about that, about how you balance everything, all of that stuff. But anyway, so you've got a 7 marker here. This is quite a rare kind of situation because you don't normally get 7 markers in AQA Chem. Now, the reason I've said flick through the paper and look for big calculation questions and then do them at the start or do them when you're not really running out of time is because this question is actually from a 2018 paper and they decided to put this as the last question. Now, imagine you're already running out of time and you've finally flicked to the back of the paper and you see a 7 marker. I think I'd lose the will to live. So just as a little bit of a tip, just have a look through your paper, and if there are questions that are standing out to you as high yield, try and get them done first because you can afford to do 1 and 2 markers towards the end, but you do not want to see a 7 marker at the end of your paper. So just as a bit of exam technique, it is also about looking at the order that you do your questions. It's not a rule that you need to go in order. It is a rule that you need to strategize which questions you're doing when. So try and flick through your paper and just make sense of what you want to get done first and kind of what you want to leave towards the end. Anyway, so let's do this. So a student added 627 mg, okay, already mg. That's not some usual kind of measurement that we see. It's usually grams. So I'm going to remember that in my mind that we're probably going to have to do something with that. Of hydrated sodium carbonate, so you've got one of those XH2O molecules, to 200 centimeters cubed of 0.25 moles per decimeter cubed hydrochloric acid. So what they've said is they've added both of those together and stirred it. They've then taken that mixture, turned it into 250 centimeters cubed in a flask, and then basically taken 25 centimeter cube portions of that and titrated it with 0.15 moles per decimeters cubed of aqueous sodium hydroxide, and the mean titer was 26.6. Right, then it wants us to calculate the value of x. Now I'm going to give you a tip for these questions. Ask yourself, what is the end result that I'm trying to find in a question? Because it says calculate the value of x, it's not told you calculate the mass, calculate the moles, or calculate percentage purity. It's literally said calculate x. So a massive tip for you guys, if you see an XH2O molecule and it asks you to calculate the value of x, that means at the end of the day, you're trying to find the MR of that substance. That's what you're trying to find. And once you have the MR, you can work it out. So XH2O, MR. So that's what we're trying to find. That's our primary goal. Now, another tip for you, 7 markers, 6 markers, anything with like big paragraphs of numbers and substances, work backwards, guys, work backwards. This is like a massive piece of advice. If you don't know already, please work backwards. So I'm saying this, what does that actually mean? The first thing I would do if I was a student answering this question is to use my kind of last substance as my starting point. So my last substance is sodium hydroxide. And I know that I had 26.6 as the volume and 0.15 as the concentration. So I know that I've got my little equation of moles, conc, and vol, and also Mr. Mole's mass. It really helps me to write them at the side because it just kind of gives me like a reminder of what, just so I don't mix up the equation. So I'm going to start by calculating the moles of aqueous sodium hydroxide because that is the last thing I've been given. So the moles of NaOH is just going to be the 26.60 divided by 1,000 to get it in from CM3 to DM3, and I'm going to times it by the 0.15, which is our concentration. Now, for that, you should get 3.99 times 10 to the minus 3. So what that's saying is that that's how many moles of sodium hydroxide it took to neutralize the hydrochloric acid that was left over, right? Because you've reacted your sodium carbonate with hydrochloric acid. Now that hydrochloric acid will have been in excess, so you've still got a little bit of it left over. What they've done is they've literally just diluted it a little bit, but that doesn't actually affect the moles. It just affects kind of the volume. But all they've done is taken that excess hydrochloric acid and decided that they want to titrate it with sodium hydroxide. So this tells us the moles of sodium hydroxide. Now, if we use the mole ratio, so if I did NaOH plus HCl, so acid plus alkali is salt plus water, so NaCl plus H2O. Do I need to balance that? Nope, I don't need to balance that. So that's a 1-to-1 ratio of NaOH and HCl. So I know if I had 3.99 times 10 to the minus 3 of NaOH, that is also how much HCl I had, right? 3.99 times 10 to the minus 3 moles of HCl. How much was that in? That was in 25 centimeter cube portions, right? What I need to do, because I'm working backwards, is convert that into 250. So 25 times 10 is 250. So I'm going to do the exact same thing with my moles. I'm going to turn it from 3.99 times 10 to the minus 3 times it by 10, and that's just going to give us 3.99 times 10 to the minus 2 moles of HCl in 250 centimeters cubed. So this is how many moles I had left after I reacted it with my initial hydrated sodium carbonate. So those two reacted, I had a little bit left over, and now we've just found out this is how much I had left over. So I'm like at the midway point now. After working backwards, I'm now midway through this, and I can now use this to figure out the rest of what it's asking me to. So that's how much I've got in 250 centimeters cubed, how much I had left over. I've also been given another value. I've been given 0.250 and 200 centimeters cubed of hydrochloric acid. And that's how much of that hydrochloric acid was initially added. So we've got how much was left over, and we've got how much was initially added. So we can obviously work out what the moles is. So using those two, we can then figure out how much of it actually reacted with that sodium carbonate. Because if I had my initial amount minus excess left over, that's going to tell me how much reacted. Just to put it into perspective, right? I'm just going to rub that out because don't think I'll have enough space. So how much initially reacted? So HCl initially added equals your 200 over 1,000 times 0.250, which is, one second. Okay, so that should be 0.05 moles. And that's how much was added to begin with. So it's like saying I added 10 apples to my basket, and the worms reacted with it, and I was left with 2 apples. So that 2 apples represents the 3.99 that was left over, and that 10 apples represents that 0.05 that I initially added. So this is how much I initially added to that basket. This is how much I had left over, the 3.99. So now I can use that to figure out what's in the middle, what actually reacted with that sodium carbonate. So hence, like, how many of those apples were eaten by the worms? I know that's a bit of a yucky example, but so the HCl reacted with the Na2CO3 XH2O equals 0.05 minus 3.99 times 10 to the minus 2, which should give you 0.0101. Cool. So that's how much HCl reacted. We can use our mole ratio now of that reaction between the sodium carbonate and the HCl to figure out how many moles of that sodium carbonate did we have, because we're trying to work out the MR at the end of the day. So if we can figure out what the moles is, we've been given the mass 627, so perfect. We can then use that to work out the MR. So let's write out the equation. So Na2 CO3 XH2O. Now, students tend to struggle with balancing an equation like this, but I want you to basically ignore that XH2O because we don't even know what the value is, so it can't affect the equation yet. All we need to do is go with the normal H2O, like basically ignore the X as you construct an equation, because you don't want it to tamper with what the balanced kind of like thing should be. So basically, just write the whole equation out. I know that a metal carbonate plus an acid makes the salt, water, and carbon dioxide. So that's why I've got this as my product. And I'm now going to try and balance it. So I've got 2 NAs on this side, only 1 on this side. So I'll add a 2 in front of that. That means I've also need to add a 2 in front of this HCl because that's 2 Cls on that side. And then other than that, I've got 4 hydrogens on like the reactant side. So I'm going to add a 2 in front of the H2 to make it 4 on that side. Other than that, is it all balanced? 4 oxygens, 3, 4. Yeah, perfect. Okay, other than that, it's all balanced. So what does that tell me? I have a 1:2 ratio between my HCl that reacted and my NO2CO3 that reacted. Well, that's great because I know that 0.0101 was how many HCl's reacted. I can divide that by 2 to work out how much of that NO2CO3 reacted. So that would be 5.05 times 10 to the minus 3 moles. So I've got my moles, I've got my mass. I can finally use that to work out what the MR would be of this whole thing. And then that is going to help me figure out X, which I'll get onto. So this is obviously, you can see that the amount of steps behind this is really what gives you that 7 marks. And if you try and follow this thought process of starting backwards and really thinking about what reacts together to produce what, that kind of puts it into a bit more perspective for you. So what was the mass? 627. So 627 mg into grams. Gotta make sure you divide that by 1,000. Yeah, it would be 1,000. So that would be 0.627 grams. So then if I'm doing my MR of Na2CO3.XH2O, it's going to be my mass over the moles. So mass is 0.627 over the moles, which is 5.05 times 10 to the minus 3. Ignore like this stuff, by the way, that's for later question. So that is going to be, sorry, I need to type that into my calc 1 second. So that should give you 124.158 1.584 as my MR. So that is the total MR of this whole structure. Now, literally, final step is to figure out what that X is. So if I know that the whole thing is going to be equal to 124.1584 as my MR, what I can do is let me work out the MR of Na2CO3, let me work out the MR of H2O, and let me see basically this that is left over, what does it equal to? So let's start with the Na2CO3. So MR of Na2CO3. So Na is 23, so that's 46 plus 12 plus 48. I literally have like these elements learned like the back of my hand because I've like it's just ingrained in my brain. 46 plus 12 plus 48 is 106. That is my MR of the Na2CO3. Now, if I was to do, let me do it here. So the MR of XH2O is my 124.1584 minus 106.0. So if I did that in my calculator, 124.1584, that gives 18.1584. So what it's saying is XH2O has to be equal to 18.1584. Now, if I know that the MR of H2O itself is 18, what I'm saying is, what could X be? Well, X times 18 is basically 18. And if X has to be a whole number, what is X? Well, X has to be 1, right? So the value of X has to be 1. Let's say that for this example, I got something like, I don't know, 54.1584 instead. Like, let's say I did all my MR subtraction, figured that all out, and it came to me that, all right, well, XH2O is equal to 54.1584. And if I know that H2O itself is equal to 18, what I would then be doing is figuring out 18 times what makes 54. Well, 18 times 3 would make 54. So it would be 3H2O equals 54.1584. Does that make sense? Like, you've got to basically, I know that there's a lot of working out here. I should have actually planned a little bit more space out here, but what you've got to do is split those into like the NO2CO3, work out the MR for that, then have a look at what is left over, and that is going to be your XH2O. If you know that H2O already has an MR of 18, then 18 times what makes the final MR that's left over for that XH2O. So you kind of got to split it up like that. And it's like all of that 7 marks for literally the answer of 1 is a bit sad, but you know, it is chemistry after all. Let me just have a look at any questions. Oh, yes. So, oh, sorry, I should have actually looked at these, but I couldn't see them. Could you please go through how have you figured out the mole ratios? Yes, I'll go through that in terms of basically like writing out the equations, right? How do you know that HCl is in excess and that HCl, because the question tells, wait, hang on. Can you attach a blank copy? Yes, I will do that. HCl, why, so as to why the HCl in the 25 isn't what reacted. Okay, let me reshare my screen and go through this with you. Let me just join via another device so I can check the questions at the same time. I think that might make it a little bit easier. Oh wait, I don't think I can. Yeah, it won't let me join on another device. Okay, it's all right. Um, Sorry, I think somebody's mic is on. Hi, sorry. Because the HCl. Okay, I'm gonna just share my screen again and go through some of this. I'll take a picture of the questions so I can go through each one. Share. And by the way, any questions I'm not able to go through, what I'll do is I'll basically work them out for you and then attach a copy onto the classroom of basically all the questions, blank version and then filled out version, just so you guys can like see it a bit more clear. So in terms of figuring out the mole ratios, so there's two mole ratios we need to figure out. The first one was at step 2 between the NaOH and the HCl. Basically, to figure out a mole ratio, you need to write out the equation, because if I know that like 3.99 like times 10 to the minus 3 is how much I had of this much, and the mole ratio is the same for both, then I know that I also had the same amount of the HCl. So to work out the mole ratio, all I need to do is write out the equation that links those substances together to figure out how much, if I had that, like if I had X amount of one, then how much would I have of the other? So all I need to do is write out the equation. Now, obviously, this one is a little bit more like tricky to visualize, but like I said, I want you to, when you do an XH2O question, when you write out the mole ratio of something like this, literally ignore the X for the time being. So let me draw this equation out for you again. So the equation that I'm trying to link, well, I know what my HCl is, and I know that my HCl reacts with the Na2CO3 because the question tells me, it says hydrated sodium carbonate is added to this much of hydrochloric acid. So I'm trying to link those two together in an equation. So Na2CO3, ignoring that X for now because it has no numerical value, so it's invalid in my equation at the moment, plus HCl. So Na2CO3 is a metal carbonate, where hopefully this is a more of like GCSE knowledge, but hopefully you remember that a metal carbonate plus a acid makes salt plus water plus carbon dioxide. So my salt is NaCl because it's your like two different, your ion, your Na and your Cl ion reacting, plus H2O, and then obviously we need to account for this carbon here, and that is accounted for in our carbon dioxide. So that's my salt, water, carbon dioxide. Obviously, I need to balance it. So I'll start with my Na. Immediately, I can see that there's two Nas on this side, but obviously only one here. So I'm going to add a 2 there. Because I've added a 2 there, now obviously that changes my chlorine to now 2. But I've only got 1 on this side. So I'm going to add a 2 here. In terms of my carbons are balanced because I've got 1 on each side. I have 4 oxygens on this side, but I only have 3 on this side, right? So my oxygens are balanced. In terms of my hydrogens, I have 4 on this side, but again, I only have 2 on this side. So what can I do? I can add a 2 to my hydrogen, and that gives me 4 hydrogens on both sides, and now also 4 oxygens on both sides. So basically, my equation is balanced. And now that I've balanced my equation, from that I can deduce that my ratio of how much HCl reacted to how much sodium carbonate reacted is 1 to 2. So if I know how much this is in moles, and that's equal to the value of 2, then all I have to do to figure out what this is divide it by that 2, because it's in a 1 to 2 ratio. In terms of the second question about how do we know that HCl is in excess and that is being titrated, the question is telling us this here. So what it's saying is the student added X amount of sodium carbonate to the hydrochloric acid and they stirred the mixture. After the reaction was complete, right? So that is one of your key things. After the reaction was complete means that one of those things had to have been limiting, right? And one of them had to be in excess because the reaction is complete once all that limiting reactant is used up. Because it tells us that whatever was left reacts with sodium hydroxide. Sodium hydroxide is an alkali, and hydrochloric acid is the only thing that can successfully be reacting and being titrated with the sodium hydroxide. So that's how I know that I had hydrochloric acid left over, because the reaction was complete, which means that obviously all my sodium carbonate has been reacted and I had my hydrochloric acid left over. The resulting solution with that excess hydrochloric acid was then titrated with sodium hydroxide, so acid and alkali titration, and then whatever like sodium hydroxide reacted, that was the same as how much hydrochloric acid I had left at the very end. So basically that I hope that kind of makes sense. But if you split the question up, and what might help is you basically having a very step by step kind of diagram. So you could say like Na2CO3 plus HCl reacts, and then from the question I can see HCl left over, HCl left over plus NaOH reacts. Like that's kind of the two-step reaction that's going on. And it's exactly why a question is worth 7 marks, just because it is genuinely like so many different things that you need to think about. But if you can try your best to visualize kind of the question and what it's asking you to do and write it down, it will really help you a lot. And then in terms of the 25 centimeter cubed, I'm a little bit unsure what you mean by that. Let me just go back on the chart. Wouldn't the resulting solution include the hydrated salt? No, because it completely reacted, remember? The hydrated salt completely reacted. It's finished and it reacted with that HCl. If the hydrated salt was finished, that means the HCl was still in excess, and that excess HCl was then titrated with sodium hydroxide. That's kind of like what it means. But yeah, wow, that actually 7 marker like took a fairly long time. Um, sorry. Okay. Since I have 20 minutes left, I think it might be worth okay, let me just go through my I'm so excited to show you guys this. I feel like it's literally gonna be like the perfect thing that you need. And it's things that I'm not gonna lie, people don't really tell you about when you're doing A levels. But I'm gonna go through each kind of phase with you, and any time left over, I can go back to doing some high yield questions, but I will just attach them to the classroom anyway. But I really want you guys to see this because it gives you a very clear game plan. And to be honest, you can copy this if you want, if that's something you want to do, but it can definitely give you some inspiration as to what you should be doing. Let's begin. So, phase one is what we're in right now, January to February. So I'm going to start up here with what I did to make sure that I was getting myself ready to receive an A star. Okay, I was ready to receive that A star. First thing that I did was made sure that my target that I was setting was as close to a realistic A star as possible. Because I sat my exams in 2024, I had a rough look at what the previous grade boundaries were, and I slightly inflated them and then set my target. Now, I remember in year 12 when I did like my baseline tests, I got AAB, so I got a B in chemistry, A and A in business and biology. Because of that, because I was already kind of receiving an A, I was like, okay, let me inflate it. But I knew for chemistry, it is so hard to get that 85%. So I kept my aim to just get 85%, not inflate it, just so I wouldn't feel as like kind of demotivated if I didn't get that A star. But what I did was inflate the results and use that as your standard, okay? And it's trust me, if you like use old grade boundaries and don't inflate them, you get yourself comfortable, like, oh yeah, I'd receive an A. But realistically, the grade boundaries do go up. So if you can try your best to inflate them, that will help you to be very realistic. My January game plan, when I had mocks especially, was to focus on weak topics. And the way I did this was to red, amber, green. So literally print out the spec and get 3 highlighters, or literally just a pen and do RAG, and get all your weak and difficult topics done early, because that gives you a longer amount of time to revisit it and to do active recall for it. So if you do the easy ones first, it kind of means that you're leaving all your hard ones to the end and you might not have enough time for it to go in your long-term memory. So try and do it the other way around. So what did I actually do? I made sure that when I had my notes, especially for chemistry, if you're doing AQA, use ChemRevise because ChemRevise has very exam specific notes and they update it like literally, I think, every couple of months. They definitely update it after every exam series to include any content that you might need. And what I did was I'd have my Chem Revise notes printed out and I would follow a revision video at the same time to make sure that the content was kind of matching up and I was understanding everything. If I needed to annotate stuff, I would also do that. Then I would actually go on to learn it once I've completely understood it. I would not recommend learning things if you don't understand them because chemistry is not just learning, it's applying. So if you are not able to literally understand what a concept is asking of you, there is no way you're going to be able to apply it. So use that technique of having your exam specific notes plus a good video. Put them together and try your best to understand a topic. Anything you kind of don't get, please just ask someone about this because you don't want to leave it as a gap in your knowledge. You then go and learn it in whatever way works for you, whether that's flashcards. For me, that is verbalizing the notes and like verbally saying it out loud and writing it down until it's in my head. Then I would actually do topic specific past paper questions, and I would learn the mark schemes of all the questions I got wrong. And that leaves like no error of stuff that you might get wrong because all the stuff I got right, I'm going to assume I'll get it right in the exam. All the stuff I got wrong, if I'm learning it, then what is left, right? What is left for me to get wrong? So try and use that as a bit of an approach to like fill in all the gaps. And then if you're doing mocks and if you're doing your obviously your real exams, that's the only time I'd recommend using full papers, because you don't want to like waste them for just like casual practice. Do topic specific papers, topic specific questions if you're just revising a specific thing. But if you're doing exam prep and like mock prep and real exam prep, you do full papers and do them under timed and exam conditions. So full silence, all in one go, timer, um, same exact equipment that you would have in front of you in your real A levels, basically. Um, so don't waste your papers. And then when I would mark my papers, obviously, again, there'd still be things I get wrong. Write them down or write down things that I frequently forget and review those like literally in the morning on my walk to school. I just pull out my paper that had like stuff I got wrong and I was like, oh, yeah, yeah, okay, just remembering, just going over that, fine, all good. So then at least I kind of like understand that a little bit more. Now, in terms of, I want to show you my diary. So this was January 3rd, and obviously it's not really we're kind of a bit beyond that now, but your principle's still going to apply. So what I would do is really, really document everything that you need to do. Have those tick boxes, and when you get things done, tick them off onto the next day. So really try and make sure that you're being very vocal about what you need to do. Again, as you can see here, I had like an after school morning. What am I doing in each free? Did I achieve that? And as you can see, if I've made my mind set that I want to do something, I would really try my best to get it done and be realistic about what you can do. Obviously, I had like quite a few frees, as you can see. So even if I just did one topic or half a paper or something in that free, it's worthwhile. And if you're in year 13 now, try your best not to waste your freeze. If you're in year 12, I wouldn't stress about this as much. But like as you can see here, one of my after school targets was to get a 16 marker done, but I didn't get it done. So I had to cross it out, and that was moved to like the next day, for example. Um, so again, let me show you what when it got a little bit intense. This is not even the intense part yet. So I'd wake up a little bit earlier, try and get an hour of studies done before I went to school. For me, morning is when I work best. Identify when you work best, guys. This will really change things for you because then you can fit your whole schedule to work around your optimum performance. So for my AQA biology essay, I was basically memorizing paragraphs for the essay. So I used to do like one paragraph in that 1 hour and I'd make sure that it was done so well and then it was just in my brain. Um, and then obviously after school and then like other things that I need to do. So try and segment your day according to when you work best. And as you can see, when I had my half term, I would have a list of things that I definitely wanted to get done. So for me, it was like a couple of business papers because I was really neglecting business at this point and I needed to get on it. And then a couple of topics for bio and chem. So that was like my rough outline. And then I'd have like a list of what I wanted to achieve, and then I would delegate each little topic to every single day. And then if you're in half term, guys, please do at least a couple of hours a day. I'm not going to sugarcoat it and say that like you only need to do 1 or 2 hours. If you're aiming for an A star, it's consistently about putting that time and effort in. And if you don't want to look at it as hours, try and look at it as topics. If you want to get at least 3 topics done a day, for example, how long is that going to take you? It might not even take you 4 hours. It might take you 1 hour with a half an hour break, another hour with a half an hour break, and then another hour, half an hour break. That's 3 hours. So realistically, for me, I had to spend 4 to 5 hours to get something done, like for my day. But that doesn't have to be the same for you. But please commit, because if you're gonna aim for that grade, you also need to work for it. So what should you actually be done like by the end of Jan? For me, I would say you should be confident with every single year 13 topic that you have covered so far. I'm not talking about year 13 topics you haven't covered yet. I'm talking about the ones that you've done so far. And if you can, try and be a little bit confident with some of your year 12 topics that you've previously found difficult. And that's kind of like a bit of a above and beyond kind of point. But definitely your year 13 topics done from September till January. Try your best to be absolutely happy with them. And if that's all you achieve in your Jan and Feb period, then still that's not too bad, okay? Because that's half of your year 13 basically covered. Okay, so that's Jan and Feb. Now let me get on to March and April. So March and April was probably one of my hardest working months. And you can see that from like all the different kind of things I had in my diary. So let me tell you what I had achieved by March and end April. Sorry, end of March and April. So I had actually covered all A-level content and I had started to attempt full papers. So let me tell you how I did that. So this, guys, this, if you do this, like, oh my God, it will really help you. I split my March into understanding, memorize, past paper question, and blur. So write down all the topics that you haven't covered yet in school for all 3 subjects. And if you can, spend a week and a half purely understanding those subjects. Don't worry about learning them. Purely understand them. So have your notes, have your videos. Anything you don't get, you need to ask a teacher or you need to ask a tutor if you can. Like, feel free to ask us. But making sure that all you need to do is understand the concept. You're then going to revisit those things when you come to memorizing. And because you've actually understood the theory, memorizing is going to be so much easier because you visualize that concept and you understand what's actually going on. So if you understand something, it's so much more easier to memorize because it's not like you're memorizing a foreign language or something. You're actually understanding what you're learning. And because you're revisiting that, it only consolidates the theory even more. And like, I don't know how I thought of this, but like, it works so well. And like, genuinely, I would recommend all my students to do this. The final third of the month was doing as many past paper questions as possible and any knowledge that I was a bit shaky on, blurting that, even making sure I was learning the past paper questions. So my whole March was me learning stuff that my school hadn't covered yet. And what did that mean? That meant I was literally sorted with all that content by the end of March. Was it like fully, like, was it like I knew it like the back of my hand? No, but that's where your past papers come in. That's where your additional learning, because you don't sit your exams in March, you sit them in May and June. So if you can even have 80% of that content sorted by March, you're in such a good spot. So you can see it here. So I literally wrote it down here, understanding week, memorizing week. So like I had it here. So this is all the topics that I wanted to basically do. So as you can see, like I had some of my biology done, a lot of my business done. Chemistry was clearly getting neglected here. But I can confirm I did get that all sorted by the end. But like you can see how verbal I was with like writing stuff down and having a clear reflective plan on what I wanted to do. So yeah, you can see I was doing a little bit of NMR, chromatography, all of that stuff. And then this was kind of like, um, oh yeah, so okay, this is a bit controversial. So I did about like 10 hours of like work in a day sometimes, which is probably too much and you will burn out. So probably don't do that. But what I did was for me when it was Ramadan, I used to like start revising from when I'd have breakfast very early in the morning all the way until the afternoon. And I used to just like really go for it with all the energy I had and then completely take the afternoon and evening kind of off. But it was something I quite recommend. If you want to follow this structure but make it less intense, please feel free, like you can do, but it is quite intense. And I don't want you all to think that this is like your make or break for an A star. I'm just saying it's something that helped me. And there's not everyone is able to hack something like this, which is so fine. Like you don't even need to worry about that. But just make sure that you at least try to do as much as you can in a day. Now, some days I would literally have days where I would do purely papers. So as you can see here, this was in April. So I would do two papers a day in the morning. So I'd start kind of follow my A-level exam time, so 9 till like 12 or however long that paper was. So morning slot, do a paper, mark it, reflect on it. So what went well? What could I do better? What kind of mistakes did I make? How will I learn like from this? Same exact thing for afternoon. And I just want to highlight here that paper threes, oh my gosh, guys, don't neglect paper threes. It's so easy to just forget about paper three because it's at the end and do them very last minute. But if you can do your paper threes earlier and then do paper one and two closer to your exams, that might be a nice way to approach it because it means you're not neglecting any of your papers. And paper three is the one that brings everyone down. So don't neglect it, please. Again, like you can just see that like how I used to communicate with myself and like it sounds a bit strange, but you can just see how like how much I used to write every single day about what I needed to do. But being so transparent and so active with my planning really helped. So March, April is a high yield time. If you can ace March and April, so phase two, you will be good. You will be so good. Okay. And then by the end of May and June, you should be doing your papers. You should be aiming to improve your score. Obviously, recognizing why you made a mistake. So, if it's a silly mistake, it might be that you might have not noticed a certain detail, or you might have accidentally misread a question. Obviously, that's very easily fixable by making sure you highlight, you annotate, you check your paper properly. If it's an understanding mistake, if it's a genuine gap in your understanding, which you can often see in topics like electrochemistry, watch question walkthroughs. Easy mode exams does amazing question walkthroughs. Let me write that down actually. Easy mode exams. But you can just search this up on YouTube. So see how they're thinking. Watch YouTube videos, speak to your teachers. If it's an application mistake, for example, so application mistakes usually are like graph questions, required practical questions, anything where like your content is never asked straightforward. So like the Arrhenius equation, I don't think I've ever seen it just asked nicely. You obviously want to memorize your mark schemes because they will test you on very similar things because it's so repetitive. So it can give you a kind of guide as to what mark points and what steps you need to learn for that type of question. But also when you revise a required practical, look at the results and look at like the graphs that they're plotting and try to make sure that you understand why they're doing it that way, or like what does every single aspect of the results mean. Again, ChemRevise is so comprehensive with this, so if you haven't checked it out already, please do. And that'll give you a great kind of baseline that you can then practice on to get better. But if you've got that prior knowledge, using previous questions, using good notes, then you will be so good in improving for application. And then obviously like other kinds of mistakes are like memory mistakes. So you might have forgotten an equation, you might have forgot a reaction equation or a reaction mechanism. So again, blurting consistently really helped me with this because I'm not gonna lie, there was things I kept forgetting. So just make sure that you identify the type of mistake, how you're going to improve from it. If you do another paper and it's got a similar question, did you get it right? That's the questions you should be asking yourself. Um, and then, so yeah, as you can see, same kind of vibe. I did have a rest day. Um, I treated myself to massage, guys. Please do it. Massages are great. It will really help you in your A-level period. I still do this now, because dentistry is no easier. So just have a rest day, then get back to it. It's very healthy. You don't want to burn out before your exams even start. And then again, you can see this was, I think, very close to my chemistry paper, paper one. So I was like proper on it. I was like, these are all the exam topics I need to know, need to really get it done. So I was like just trying to work my way through. And then this was like the one of the days that I actually had my paper. So it was a morning paper, A-level bio. So like for me when I'd come home, I think I'd nap for an hour because I was quite tired, and then I'd just go straight back in with more revision because the exams are coming up. Now, as you can see here, there was things throughout. You can see in all my images, there were things I weren't able to get done, and that's okay. You don't have to hit every single target every day. It's just about you showing up, giving it your best, and trying again, the next day. So anything you can't do one day, just do it the next day. Um, and yeah, like that. I'm gonna just stop sharing just to check questions, like any questions you guys have. But please feel free to ask as many questions as you want about this. I know it's a lot of information, but like it is so important that you map out what you need to do. Because if you go into it with no strategy, then like where are you even going? What's your end goal? If you don't know what that is, how do you expect to improve? So really try and kind of do that. Um, da-da-da. Um, so one second. Um, yeah. Yeah, don't worry, guys. I don't want you to panic about sort of like how vigorous this is. In like April and May, you should expect it to get vigorous. If you think that it's going to be an easy ride of an hour a day of revision, then you're wrong. I'm going to clear that up for you now. Um, a mixture, some of this was in April half term, so like start first 2 weeks of April. I will share this all with you on the classroom, so don't worry. So interview prep at the start of the year. What I used to do was I had one day on the weekend that I would do quite a few hours of interview prep. My interview prep only lasted until February, and I had my interviews at the same time as mocks as well. So it was a little bit like kind of difficult because I had mocks, but I also had interviews. Now, interviews are a one time, like you've got one shot, you've just got to go and achieve it. So when it gets close to them, please give more emphasis to that. You've got to shake your priorities up a little bit. But at the end of the day, making sure that you're dedicating enough hours, maybe on a weekend evening, just a full day just for interviews. And then the rest of the time you can do your A-level stuff. But trying to get your mock interviews booked in and trying to make sure that you practice your answers with your family and friends, that all really matters. And all it takes is like maybe an half an hour, like a day, to just do that a little bit more. But when your interviews are up and coming, just kind of deprioritize A levels a bit. Cramming organic chem. Yeah, I mean, cramming organic chem, if you just focus on the stuff that you're always getting wrong, then at least you've kind of nailed that. But you're just gonna have to create a very intense routine to get things done. And just making sure that you do practice questions because it's not just about your content, it is about being able to apply it. Um, Late med interviews in March. So I guess same approach, but because you're trying to do a little bit more A-level revision in March, you might want to instead kind of do more revision before for like A-levels and then have a week or two in March that you're focusing solely on interviews. So maybe swap it around. So rather than, because for us dental students, like we have a little bit more emphasis like in February and stuff for interviews. But if that's for you in March, then you can just revise A levels in Feb, but then closer to March, try and do more med interview stuff. But if you can do even half an hour a day in the morning, in the evening, consistently, that's really all you need, and then scale it up a little bit more. You can apply this to all subjects, absolutely. Um, so recent A level, any advice on how to approach this? Um, okay, well, in terms of resitting, I mean, in terms of your approach to chemistry, I mean, I've sort of gone over this a little bit right now, but if you can maybe get access to your original papers that you got a B in, reflection is very important here because you trying to figure out how you've actually got that grade and how you can get higher than that. That's where it's going to improve. So if you can reflect on what your weak topics were, did you do enough practice? Did you learn your required practicals? Did you do your reaction mechanisms? It's kind of like you figuring out what you did wrong the first time round and doing everything you did the first time round, but then improving on that mistake. That is literally you figuring out where you made a mistake and never doing that again. That's what allows you to improve. So really reflecting on that. How often did I take a rest day? At times, not a lot, which is not really good, but at least like once every 2 to 3 weeks, was like a complete rest day. But for me, my cutoff was like 6 p.m. I can't do any work after 6 p.m., but I can do work at 4 a.m. So that's just kind of the way it works for me. So if you can have that kind of approach of cutoff time after like X amount of time, I'm just dedicating it to myself. I'm doing a face mask, I'm relaxing, that's fine. But then I know the next day I'm gonna be up and going for it again. Access Classroom, I think I can just share a link to that, to be honest. Um, mm, mm, mm. Distract yourself while waiting for decisions to come out post interview. Oh, this is the most anxious like time there is. Like I completely get you. It's a very difficult time. However, you know, with like interviews, right? With the post interview waiting, what difference is it gonna make if you think about it versus if you don't? Like, genuinely, is it gonna change your outcome? Absolutely not. If you anxiety induce yourself, you're actually going to end up underperforming in everything else that you're focusing on. So you need to think, for myself, I need to be strong and kind of focus on the now and what needs to be done. You know, you finish an interview, move on. What's next? Is it A levels? Is it another interview? Focus on what's happening next. And after my interviews, I actually wrote down how I felt. And then, like, after I got it off my chest, I kind of tried not to focus on it too much. And genuinely, you're gonna underestimate your performance because I thought I would definitely flop my interviews, but I got offers from all of them. So don't even worry. Like, please focus on what's next rather than what's happened because there's no point. You're not changing your outcome and you're definitely overthinking it. Um, the recording will be on the classroom, hopefully. Um, mhm. I lock in at 12 a.m. but can't do anything before. Yeah, that's all right. That's literally all right. No sleep on no grades. Yeah. That is definitely a dilemma. I lost out on a lot of sleep, to be honest. Um, but hey, it's literally a temporary kind of thing, isn't it? Um, you've got to get that A star. There is a link to the classroom on somebody's just replied. Um, so that's let me just put it. But yeah, if you guys do have questions, always feel free to ask and like make sure that you kind of get all the knowledge that you need from different sources as long as they're good sources. But I hope you found this useful. Um, it was a quite an in-depth kind of guide. Oh, no problem. But yeah, like make sure that you work hard, guys. If you have a goal, commit to it for yourself. Not a day goes by where I don't think about how happy I am that I locked in. If I didn't lock in 2024, like when was I gonna lock in? So definitely commit to yourself. Do it for you. Um, the classroom code is that recordings and stuff will be posted on there. I'm gonna post like the whole session of today on there anyway, and all the questions. So don't worry. And if you've got any questions, you know where I am. Um, yeah, no problem, guys. Have a nice Sunday. Can you go from a C to an A? I went from a B to an A star. So yes, I think that's the same kind of principle. Depends how much work you put in, depends on if you're working smart as well as working hard, but you absolutely can. You can go from a C to an A star if you want. I genuinely believe in that. I genuinely believe you can do things if you put your mind to it. So if you can work, if you can want an A star and if you can work for it, then absolutely. You put the code. I think you just like have to press like the plus and then it says like join classroom and then you put the code in, I think. Um, yeah, might be worth sending a Google Classroom link into the chat actually. Like the main WhatsApp chat. We do that. Uh, I'll do that for you. Classroom. Google Classroom. Feel free to leave by the way if you don't have any questions. Um, what advice would you give for interview prep with 1 week left? Do so much prep. Do like a mock the day before. If you can do like if you've got a week left like from now, try and do get like two mocks done, like one at the start of like your week and one towards the end. Um, Revise like your content, but more importantly, like the common questions. If you know like kind of what interview you're revising for, you should have a rough idea of the specific stations in a sense, or at least a little bit of an insight into what you should be expecting, right? So whether that's data interpretation or whether that's role plays. So have at least two mocks that are very specific to that university. And in the meantime, focus on the content that you need for each of those stations, and like proper practice your replies. Do it with as many people as you can, as many hours as you can. Because like you don't want to blow this opportunity. You really, really want to do well. Mm. I get that. Is that do you think that is nervousness? Or do you think that's like um kind of like you not knowing the content? Or when you have revised, have you learned a paragraph or have you learned it as bullet points? Like what is your approach? So do you feel nervous when you answer? How do you revise? And when you do you have thinking time? And if so, do you kind of actually use that thinking time properly? Um, I try to use good words which make me stop and think. Okay. If you're using buzzwords like empathy, communication, you know, autonomy, things like that, that's fine. Like you should be using those buzzwords. But if you're trying to use complicated words like furthermore, or I don't know, something trying to sound a little bit more techy, you really don't need to do that. Like if you the kind of more simple and genuine your answers are, that kind of conveys authenticity. Um, but when you are learning bullet points and when you're expanding, as well as that, it's actually utilizing your thinking time to just in your head come up with what you're going to say to that interviewer. Now, in terms of when you actually go and approach a question, so I always like kind of like to ask students to verbalize their approach. So if it was asking you like the pros and cons of water fluoridation, try to like signpost to the interviewer, and that makes it easier for you as well. So in your thinking time, you're going to think of the structure that you're going to use. So